Geologists are always looking for signs of earthquakes, gas emissions, and surface changes at Yellowstone National Park, but they're also searching through bones. Bones don't immediately seem like the key to predicting a supervolcano eruption, but these bones might hold important clues about how long we have before the next eruption. And if scientists can use them to understand how Yellowstone behaves, they can help keep people safe when the next eruption does occur. So let's go back in time by about 640,000 years to see what these ancient bones can tell us about Yellowstone's future. Yellowstone National Park is best known for its geysers, hot springs, and most importantly, its supervolcano. The area has been a caldera, a huge crater left over after an eruption for millions of years. In fact, there have been 3 major eruptions at Yellowstone in the last 2 million years. But this volcano isn't like most volcanoes. It doesn't build up a cone with each eruption. Instead, after each blast, lava flows out over the existing caldera. That means that the oldest rocks aren't at the bottom of the volcano, but rather form the surrounding peaks. Each new layer of rock gets younger as you move closer to the center of the park, because that's where the newest eruptions have occurred. But understanding what happened at Yellowstone in the past can be kind of tricky. Most of the time when something erupts, especially something as big as Yellowstone, it destroys evidence of anything that was living nearby. And when large parts of the land are destroyed and reformed over and over again, it can be hard to figure out the timeline of those eruptions. That's why scientists turn to fossils to reconstruct Yellowstone's history. They just have to find some. Now, right after the last eruption, which was about 640,000 years ago, there weren't many animals around. There was a brief period of time where life couldn't exist in the area because of all the ash covering the landscape. Then, microbes moved back in, followed by insects, plants, birds, and mammals. But the area didn't return to the way it was before the eruption, even after all those animals moved back in. Scientists think this is because the eruption changed the climate. Before the eruption, the ice sheets had started to advance in North America. After the eruption, the entire continent got buried in ash, blocking the sun and cooling the planet down. During this period, called the last glacial maximum, it was too cold for things to thrive. So only tough plants and animals like bison, camels, and wild horses survived. But after the volcanic winter ended, a new ecosystem blossomed. Hibernating ground squirrels were the first to return about 600,000 years ago. This was followed by other small mammals like rodents and rabbits. But it took a few thousand years before larger animals like deer and elk returned. All these creatures left behind their bones and other body parts, creating a treasure trove of information for scientists today. So now let's fast forward about 500,000 years into the future. Today, the largest animals in the area are elk, bison, and wolves. But in about 500,000 years, scientists predict the area will likely be home to animals similar to modern-day bison, but also to species like a giant ground sloth, essentially a massive version of a sloth with humongous claws. And they won't be completely alone. Wolves, deer, and pronghorns are also predicted to roam the land. That prediction comes from studying the past. We know that following a large disturbance like a volcanic eruption, smaller animals move in first, followed by larger animals later on. By looking at the types of fossils from different layers of rock, scientists were able to develop a model for the recolonization of Yellowstone after a massive eruption. They identified a group of plants and animals that probably arrived within 100 years after the eruption, and others that arrived a little later. For example, small mammals showed up shortly after the eruption, while large mammals appeared about 1,000 years afterwards. Using this model, scientists can predict what animals are likely to be around in the future. But in order to use that model, they need to understand the timeline of Yellowstone's future eruptions. Now, no one knows exactly when the next eruption will occur, but scientists have learned enough about its behavior to estimate the likelihood of an eruption in any given year. Between 1985 and 1988, the U.S. Geological Survey conducted the Yellowstone Volcano Observatory, a series of experiments designed to monitor the volcano. Since then, the monitoring network has grown to include dozens of seismic recorders, hundreds of GPS stations, and dozens of other instruments that collect data on everything from gas emissions to the tilt of the land. All this data helps scientists keep tabs on the magma chamber beneath the park. When magma builds up beneath the surface, the ground swells up. If the magma chamber is filling up quickly, the land rises quickly. If it's filling up slowly, the land rises slowly. The same goes for earthquakes. When the magma chamber is getting full, the pressure from the magma causes more earthquakes to occur. More frequent earthquakes could mean that the reservoir is filling faster, and an eruption could be on the horizon. Scientists also look at thermal features, like geysers and hot springs. If the water temperature suddenly increases or decreases, that could be a sign that magma is moving around underground. But while scientists can monitor these signs, they can't actually tell how much magma is beneath the surface or how fast it's accumulating. All they can do is observe what's happening above ground. But there is one thing they can measure directly: the gases being emitted from the ground. Magma contains dissolved gases that get released as it moves upward. As these gases rise, some escape into the atmosphere, but others dissolve into groundwater, creating vast underground reservoirs of superheated water vapor and carbon dioxide. These gases can travel through the rock and eventually reach the surface, creating a carbon dioxide footprint of the magma chamber. By measuring the size of this footprint, scientists can get an idea of how much magma is beneath the surface. But they can also learn about its chemistry. There are several places in Yellowstone where CO2 and other gases bubble out of the ground. These areas are called CO2 seeps, and they're created when pressurized fluids move through the rock. Sometimes the gas bubbles come out of the ground in predictable pulses, and sometimes they just bubble along steadily. While researchers used to think these seeps were random, recent research has shown that they actually respond to earthquakes. These findings may shed light on the frequency and size of Yellowstone's eruptions. Magma chambers usually contain pockets of gas, and when the pressure is high enough, that gas gets released, causing an eruption. Because the magma chamber beneath Yellowstone is so deep, the gas dissolves in the surrounding rock and groundwater, and then it makes its way to the surface in these CO2 seeps. So, by analyzing the chemical composition of the gas and the rate at which it's released, scientists can better understand how the magma chamber is evolving over time. In fact, one study found that during times of increased earthquake activity, the amount of carbon dioxide being released from the seeps increased as well. On the other hand, when the magma chamber wasn't very active, the carbon dioxide release decreased. This is good news for scientists because it turns out the gases coming out of the ground may be a direct link to what's going on beneath the surface. All of this data from the past few decades is helping scientists better understand how Yellowstone works, and they're passing that knowledge on to the public. Every 5 years, the USGS releases a report on the likelihood of an eruption in any given year. According to the most recent report, the chance of an eruption in the next 30 years is less than 1%. This may sound low, but it's still considered high risk because if it did erupt, the effects would be catastrophic. That's why scientists are working hard to share their research with everyone from park rangers to policymakers. Their goal is to make sure that if Yellowstone does erupt, people are prepared. That includes making sure the public understands what might happen in the aftermath of an eruption and how they can stay safe. Some scientists even work with emergency managers to create plans for evacuations and other responses. It's not possible to predict exactly when an eruption will happen, but by understanding the risks, we can better protect ourselves and the incredible animals that live in and around Yellowstone National Park. And it's thanks to the work of scientists studying the past that we have any hope of predicting Yellowstone's future. You'll never know where you might find fascinating fossils or the next scientific breakthrough. That's why we've made our mission to bring you the finest science news from around the world every week through our free email newsletter. And you can find the stories that we cover in our podcast. Thanks for watching and learning with us.